What kind of predator can exist in two worlds that were never meant to meet? The ocean's surface is a realm of light, wind, and breath. The abyss below is a place of pressure, darkness, and biological restraint. In nature, boundaries are usually absolute. Creatures belong to one environment or the other. They are shaped by it, limited by it, defined by it. And yet, there is a mammal that moves freely between sunlight and void. A creature that breathes air, nurses its young, and communicates in complex social codes, yet spends much of its life hunting in a darkness so complete that even vision becomes irrelevant. That animal is the sperm whale. To understand it is not simply to understand a species. It is to confront a paradox in biology itself. An adult male sperm whale can stretch to nearly 60 feet in length and weigh more than 50 tons. That number is easy to say. It is harder to truly picture. 50 tons is not simply size. It is presence. It is inertia. It is the kind of mass that alters the water around it before it even moves. When a bull sperm whale turns, the ocean must turn with him. His head alone can span almost a third of his entire body. It rises forward in a squared, monumental block, not tapered and delicate, but solid, architectural. From a distance, he does not resemble a streamlined marine animal. He resembles a structure, a moving promontory of living tissue drifting through blue space. Unlike the blue whale, which holds the record as the largest animal ever to exist, the sperm whale is not engineered for graceful filtration. The blue whale is elongated and refined, built to cruise vast distances while sieving microscopic life from the water column. The sperm whale is built with a different intention. Dense muscle layers reinforce his body. His front half carries immense weight, as if evolution concentrated force forward. He is not shaped for passive feeding. He is shaped for descent, for impact, for pressure. And his world is not horizontal. He ranges across every major ocean basin on Earth. From the cold margins of Antarctica to the warm gyres of the tropics, he appears wherever the seafloor drops into darkness. He does not cling to coastlines. He does not require continental shelves. He seeks depth. The open ocean is not a surface. It is a column. Most marine life inhabits a thin, illuminated skin near the top. The sperm whale occupies the full vertical expanse. He moves from sunlit water into blackness, thousands of feet below, then returns again. His size is not excess, it is equipment, and that verticality is the key. Below a few hundred meters, sunlight begins to surrender. The blue thins, colors drain away. What was once a bright and shifting surface becomes a dim, suspended haze. By 1,000 meters, illumination no longer guides life. True darkness begins, not as a dramatic curtain drop, but as a gradual erasure of certainty. Temperature falls toward the edge of freezing. Metabolism slows. Oxygen becomes scarce and unevenly distributed. Every movement requires intention. Every adaptation carries cost. But it is pressure that defines the deep. With every 10 meters of descent, another atmosphere presses inward. The increase is steady and indifferent. At 3,000 feet, more than 100 atmospheres weigh against every surface. At 10,000 feet, pressure is no longer simply environmental. It is structural. It becomes a force that reshapes biology itself. Gas-filled spaces cannot negotiate with it. For mammals, lungs are elegant instruments of exchange. They are soft, elastic, and filled with air. At the surface, they are life. At depth, they become vulnerability. As pressure rises, air compresses, cavities shrink, delicate tissues strain. Without protection, collapse is not gradual, it is decisive. Deep-sea fish follow another path. Many lack large air cavities altogether. Their bodies are built without buoyant bladders that would implode under pressure. Their tissues are saturated and stabilized to match the surrounding sea. The chemistry of their cells is calibrated to endure weight that would overwhelm surface dwellers. Yet this adaptation binds them to depth. Bring such a fish upward too quickly, and equilibrium vanishes. Cells expand, structures distort. The very pressures that once held them together are gone. They are not malformed creatures. They are precisely formed for a world we rarely see. Nature rarely grants exemption from trade-offs. To live in air requires space within the body. To live in pressure requires surrender of that space. You are shaped by the medium you inhabit. You become either a creature of breath or a creature of compression. To exist fully in both is almost unheard of. The sperm whale does not fight the deep. It does not brace against pressure or attempt to overpower it. It yields. As the whale descends, the transformation begins gradually. The rib cage is not a rigid cage in the human sense. It is flexible, capable of folding inward under increasing force. The lungs do not remain inflated in defiance. They collapse in a controlled sequence, guiding air away from the fragile alveoli and into reinforced upper airways where compression is less destructive. This collapse is not injury, it is design. By allowing the lungs to compress, nitrogen absorption into the bloodstream is minimized. The risk of decompression trauma during ascent is reduced. The whale avoids the physiological crisis that would incapacitate most air-breathing mammals at similar depths. But the deeper adaptation lies elsewhere. During a dive, the lungs are not the primary reservoir of oxygen. Instead, oxygen is stored in the blood and in the muscle itself. High concentrations of hemoglobin increase carrying capacity within the circulatory system. Even more critical is myoglobin, an oxygen-binding protein saturating the muscle tissue. Myoglobin acts as a molecular vault, holding oxygen tightly and releasing it slowly as needed. In effect, the whale carries its breath inside its body rather than inside its chest. As descent continues, the heart rate slows dramatically in a response known as bradycardia. Circulation to peripheral tissues decreases. Blood flow is conserved and directed toward the brain and other essential organs. Metabolism adjusts downward. Energy is rationed with precision. This is not a frantic sprint into darkness. It is a measured, controlled transition. Dives exceeding 60 minutes are common. Some individuals have been recorded approaching depths near 10,000 feet, entering pressure regimes that would collapse submarines not specifically engineered for such environments. Yet the whale returns, not because it resists physics, but because it accommodates it. Where other mammals confront the deep as a hostile force, the sperm whale treats it as a negotiable condition. It does not conquer pressure. It cooperates with it. At depth, vision becomes an unreliable guide. Sunlight does not filter into these layers in any meaningful way. What remains is not shadow, but absence. Even large, well-adapted eyes provide limited advantage when photons simply do not arrive. In that environment, sight is not a primary sense. It is an afterthought. So, the sperm whale did something remarkable. It converted sound into sight. Within its immense head lies the spermaceti organ, a vast chamber filled with specialized waxy oil. This structure is not incidental anatomy. It is a finely tuned acoustic instrument. Muscular and connective tissues surrounding it help channel and focus sound waves generated in the nasal passages. The whale produces a series of powerful clicks that can exceed 200 decibels underwater. These are not casual noises. They are concentrated bursts of acoustic energy, among the most intense biological sounds ever recorded. In water, sound travels farther and faster than it does in air. Each click moves outward in a widening cone, penetrating the darkness like an invisible beam. When it strikes an object, whether flesh, bone, or soft-bodied invertebrate, a portion of that energy returns as echo. From those echoes, the whale extracts detail. Distance is calculated by the time delay between emission and return. Density is inferred from the strength of reflection. Movement is detected through subtle shifts in echo pattern. Orientation becomes clear through the geometry of returning signals. In effect, the whale builds a three-dimensional model of its surroundings without ever seeing them. Primary targets include large cephalopods, such as the giant squid and the colossal squid. These animals inhabit depths that remain inaccessible to most marine predators. Their bodies are soft, elusive, and adapted to darkness. But camouflage offers little protection against acoustic detection. The sperm whale's descent is not random wandering through empty space. It is deliberate navigation guided by sound. Each dive is structured. Each pulse of echolocation refines the map. In a realm where light fails completely, the whale does not search blindly. It listens its way forward. Evolution does not grant dominance in isolation. Wherever one lineage advances, another responds. Power invites countermeasure. In the deep ocean, that exchange has unfolded for millions of years between the sperm whale and its most formidable prey. The giant squid and the colossal squid are not passive inhabitants of the abyss. They are equipped for resistance. Their tentacles are lined with rotating hooks or serrated suckers capable of gripping thick skin. Their strike is fast, directional, and precise. In total darkness, speed becomes survival. We rarely witness these encounters directly. They occur miles below the surface where cameras struggle and light cannot follow. Yet the evidence surfaces with the whales themselves. Across the heads and flanks of adult sperm whales, pale circular scars form patterned constellations. Deep rake marks run along their skin, punctures heal into textured ridges. These are not incidental abrasions, they are records. Each scar is a receipt of contact in a place no human eye has seen. Inside the stomachs of examined whales, researchers have recovered thousands of indigestible squid beaks. Soft tissue dissolves quickly in digestive acids, but the hardened chitin of the beak remains. Over time, they accumulate, a silent archive of repeated hunts. The squid evolved speed, concealment, and weaponized appendages. The whale evolved mass, acoustic precision, and extraordinary durability. Neither species is ornamental. Neither exists as background to the other. For millions of years, this exchange continued in darkness. It is an arms race conducted without spectators, without myth, without spectacle, only pressure, sound, and impact. Each adaptation in one lineage exerts selective pressure on the other. Stronger hooks demand thicker skin. Better camouflage demands finer acoustic resolution. Increased depth tolerance in prey requires deeper pursuit in predator. Over geological time, they have shaped one another. Dominance in the deep is not static. It is negotiated repeatedly through contact, through survival, through incremental refinement across generations. In the abyss, evolution is not dramatic. It is patient. When the sperm whale begins active echolocation, the ocean does not remain acoustically neutral. Its clicks travel outward with measurable intensity, filling the surrounding water column with structured sound. In those moments, the deep sea is no longer an anonymous space. It becomes illuminated by acoustics, and other species respond. Many marine mammals rely on sound as their primary sensory and social medium. In regions where sperm whales are actively hunting, researchers have documented reductions in vocal activity among neighboring animals. Communication shifts. Calls become shorter or less frequent. In some cases, silence replaces signal. Beaked whales provide one of the clearest examples. These deep-diving cetaceans have been observed modifying dive patterns in areas where sperm whales are common. They shorten vocal phases during descent. They delay clicking. They minimize acoustic exposure during the most vulnerable stages of foraging. The adjustment is subtle, but consistent. It reflects recognition. Even the highly social orca, often described as an apex predator in its own right, may alter movement patterns in specific contexts when confronted with large adult male sperm whales. Direct predation on healthy adult males is rare. Encounters are not impulsive. They are calculated. The presence of a top predator does more than remove individuals from the food web. It reshapes behavior across species. Migration corridors shift away from frequently hunted canyons. Foraging windows adjust to avoid peak activity periods. Communication strategies evolve in response to acoustic detection risk. Over time, these behavioral adjustments become patterned. What begins as immediate caution can mature into generational habit. Silence itself becomes adaptive. In ecology, this is sometimes described as a landscape of fear. Not a dramatic fear, but a structural one. Animals alter movement and energy expenditure not only because of direct mortality, but because of the possibility of it. Predators shape ecosystems not only by what they consume, they shape them by what others avoid becoming. The sperm whale possesses the largest brain by mass of any known animal on Earth. That fact alone invites speculation, but size by itself does not define intelligence. What matters more is how cognition is expressed in behavior. In sperm whales, complexity is not abstract, it is observable. Females and juveniles live in stable matrilineal units that can persist for decades. Daughters remain with mothers. Calves are raised within extended kin networks. Social bonds are not temporary associations formed for convenience. They are durable relationships that shape survival and learning across generations. Communication within these groups relies on patterned sequences of clicks known as codas. These codas are not random pulses. They follow rhythmic structures that vary between populations. Distinct clans exhibit unique acoustic dialects, subtle but consistent differences that function as cultural identifiers. Researchers have documented these dialects persisting across years and across ocean basins. Cultural markers are transmitted socially rather than genetically. Young whales learn the acoustic signatures of their clan much as human children absorb language patterns from family. This continuity suggests more than instinct. It suggests memory and transmission. When threatened, these social units can coordinate defensive behavior. Adults may arrange themselves into a circular formation, positioning calves at the center and orienting their powerful tails outward. Such a response requires spatial awareness, synchronized movement, and rapid communication. It is not the action of isolated individuals reacting blindly, it is a collective strategy. Deep dives are often solitary. Adult males in particular may range independently across vast distances. Yet even solitary hunters are shaped by early social learning. Techniques, vocal patterns, and foraging preferences develop within community before dispersal. Dominance in the deep is not merely physical. It is organized. The sperm whale's presence in the ocean is not that of a drifting giant. It is that of a structured society moving through a vertical world. Survival may involve individual descent into darkness, but the knowledge required to survive there is inherited through social continuity. In that sense, the whale does not descend alone. It carries its culture with it. The lineage of the sperm whale stretches back millions of years, deep into epochs when the outlines of modern oceans were still settling into place. During the Miocene, fossil relatives moved through ancient seas, some bearing formidable teeth along both jaws and reaching sizes that rivaled or exceeded their living descendants. These were not gentle grazers. They were macropredators, shaped by competition in warm prehistoric waters. Over geological time, continents shifted, seaways opened and closed. Climates cooled from greenhouse warmth toward ice age cycles. Productivity patterns in the ocean reorganized. Prey species rose and declined. Entire marine communities were restructured. Yet through these transitions, one strategic thread remained intact: vertical mobility, combined with acoustic precision. While coastlines migrated and currents changed course, sperm whale ancestors continued to exploit the deep pelagic column. They descended beyond the reach of light and returned again, refining a method that allowed access to food resources largely untouched by surface competitors. Long before humans charted trenches or assigned names to abyssal plains, these whales were navigating them with biological sonar. Long before physics described hydrostatic pressure or acoustics quantified decibels, evolution had already converted those principles into living mechanisms. 20 million years is not simply duration. It is enough time for ecosystems to bend around a recurring force, for prey species to evolve countermeasures tuned to a specific sensory system, for behavioral caution to become embedded within lineage. Predation at that scale does not disappear without consequence. Morphology reflects it. Behavior reflects it. Distribution patterns reflect it. The whale did not merely persist through deep time as a passive survivor. It acted as a shaping pressure within it. What kind of predator can exist in two worlds that were never meant to meet. It would have to be one that does not wage war against its environment, but instead conforms to it with precision. One that understands the rules of air and the rules of pressure, and yields to both without surrendering function. One that trades acceleration for endurance, lung volume for blood chemistry, eyesight for acoustics. It would be a creature that accepts collapse as part of descent and returns to the surface without fracture. The sperm whale does exactly that. At the surface, they are sometimes seen resting vertically, suspended in quiet formation. Bodies drift head down, tails angled toward open water. From a distance, they resemble dark pillars beneath the moon, motionless against a gently moving sea. To an observer, the posture suggests stillness, almost absence. Yet this stillness is not emptiness, it is intermission. Beneath that calm exterior lies a biological memory shaped over millions of years. A memory of depth where light fails, a memory of pressure that compresses steel, a memory of silent pursuit guided not by sight, but by echo. They are not creatures of sunlight alone. The surface does not define them, nor are they creatures bound exclusively to the abyss. The deep does not confine them. They move between both realms with measured continuity. They are a living bridge between two environments that rarely overlap. A reminder that evolution sometimes produces not a specialist confined to a single niche, but a mediator between extremes. If you find yourself drawn to places where light fades and certainty dissolves, where physics feels less forgiving and silence carries meaning, then understand that the ocean still holds presences shaped by forces far older than our maps. There is more beneath the surface waiting.